Hello, my name is Tapiwanyemba. I am with the Genius Academy. Today we are going to do grade 9 Pythagoras Theorem, even though this content can be useful to any level of mathematics which requires the study of Pythagoras Theorem. So this is an introductory tutorial or lesson, and we are going to be doing other lessons as we progress. So now, the first thing we need to learn when we are studying the Pythagoras theorem. Pythagoras theorem. The Pythagoras theorem. So a funny fact is, if you have watched this series which is called Atlantis, the name Pythagoras, there was a character playing Pythagoras there. So you might have a hint of who Pythagoras was. But what I know is Pythagoras was a Greek philosopher who helped craft this theorem of finding lengths of a right-angled triangle. So a theorem is from the root word theory, which just means a framework of ideas developed to define a certain hypothesis. These definitions are not necessary in mathematics, but they are just side notes. So when we talk about the Pythagoras theorem, the first thing which we should be cognizant of is, number one, we are going to be talking about a right-angled triangle. A right-angled triangle. So there are mainly three types of triangles which we are not going to be discussing. Our focus is directed to a right-angled triangle. So the features of a right-angled triangle now are, so let me just diagrammatically show you what a right-angled triangle is like. So this becomes our right-angled triangle. What makes this triangle right-angled is a 90-degree angle. So we must have two lines which meet perpendicularly. And I'm not going to be writing down the names of certain things I'm going to be mentioning, because they are not as much necessary in understanding the mathematics around the Pythagoras theorem. So this is the 90-degree angle. Now, opposite the 90-degree angle, this line is a special term. It is called the hypotenuse. The hypotenuse. And a feature of the hypotenuse which is important is this is the longest side, if you may, or line on this triangle. Then we have these two sides, lines which are meeting perpendicularly to form this 90-degree angle. So these are the features of a right-angled triangle, and this is what we are going to be using. Now let us put another right-angled triangle. Then let us label our sides A, B, and C. Now, what is the Pythagoras theorem? So my uncle used to tell me that mathematics is just made up of things you should know. And sometimes it's wiser not to ask why. So the most important question in mathematics is how, not why. Because science is actually a quest by men to answer certain questions. And certain sciences require why, which might be social sciences, psychology, and the like. Some sciences, they'll answer when, and I would love to consider history a science. some sciences answer what, and mathematics usually answers how. The how part is the most important. So the Pythagoras theorem, the Pythagoras theorem, the Pythagoras theorem is a squared equating b squared plus c squared. This is the Pythagoras theorem. A squared is equals to b squared plus c squared. But to present everything you are expected to know, we can redo this right-angled triangle. And this time, instead of marking sides, we are marking vertices, or rather, we are marking points. So the Pythagoras theorem in this case, the Pythagoras theorem in this case will be bc squared, because it's bc is equal to ab squared plus ac squared. That is it. So the hypotenuse, the other thing is we can actually shorthand it, write it in shorthand like just hyp. So an important note to take home is it is the hypotenuse squared, which is equal to side squared plus side squared. The hypotenuse squared is equal to side squared plus side squared. That is important, and this defines the Pythagoras theorem. So you might ask, why learn about all this? What is the need? So the basest application of the Pythagoras theorem was during the time where Egyptians, or rather Israeli slaves, were building the pyramids. And there was need to know the lengths of the pyramids for them to make perfect triangular prisms. So this is the mathematics they were using to determine the length. So the applications of this theorem, which I want to term basest or just base applications. Base applications, they are: number one, finding missing side. Finding missing side. Then number two, how can I put this? Okay, I can say determining or determining the correct pronunciation if a triangle is right angled. These are the two basic applications of this theorem. So I'm going to run through two examples. Number one, finding a missing side example. Then secondly, the determination of whether a triangle is or is not a right-angled triangle. Then I will give maybe two questions as take homework, so that you can write your solutions, and possibly my email will be available for you to send over your solutions, or rather you can use the comment section, whatever is convenient to you. So stay with us. So that is our example one. So I said example one, to show you that this is the first illustration of how we basically apply the Pythagoras theorem. So that is the triangle. It's right angled because of this 90-degree angle. And you should also know that apart from the hypotenuse being the longest side of the three, the hypotenuse is also always opposite the 90-degree angle. So you look at the line opposite the 90-degree angle. Or if you like fancy language, you can say you look at the line which joins the two perpendicular lines, whatever way you take it. Because at times the triangle is going to be rotated and they're going to insert a 90-degree angle, and they ask you to calculate uh, by use of Pythagoras Theorem. And you might be confused. It might not always be obviously and neatly positioned as in this case. So you should know that. Now we are tasked to find C. So the first thing is we have to confirm if it is a right-angled triangle in order for us to be able to use the Pythagoras theorem. And by seeing this 90-degree angle, we know it's right-angled. Then what do we do? Firstly, we put our Pythagoras theorem. A squared is equals to b squared plus c squared. Now, it's important to know what A is, B is, C is. And I encourage you in the meantime to actually determine what A is. So you can actually say where A is equal to A squared is on its side, and this side is the left hand side. So this is the left hand side. So A is the hypotenuse. The hypotenuse in this case is 5. So you are going to say what? Where A is 5, then B you can take it to be 3, and C you can take it, and C is what you are looking for. Right. Now, having correctly determined what A is, B is, and C is, then we have to substitute A, B, and C into our Pythagoras equation, if you may. So what is A? A is 5. So we are saying 5 squared is equal to, what is B? B is 3. 3 squared plus C remains C, because that's what we are looking for. So my advice is you should actually put all things, rearrange sort of, so that your unknown variable C is it's independent on its own side, and all the numbers are arranged on the other side. So we have to transfer this 3 squared. Now, this 3 squared is positive, even though the plus is not visibly put, but we should know that it's positive. And when it goes over the equal sign, it changes from positive to what? To negative. So 5 squared, which we already have, minus 3 squared to signify the change, will be equal to c squared remains. Why aren't we putting this plus? Because when a variable or figure is on its own, we don't put the positive sign, even though we know that it's positive. Now we interpret this by calculation. 5 squared is just 25, and 3 squared is also 9. So it's 25 minus 9 is equals to c squared. What is 25 minus 9? 16 is equal to c squared. Now what do we have to do? If we need to remove this square, we have to introduce the square root. So we square here, and we also square here. Therefore, c, the square root of c squared is c, is equal to the square root of 16 is plus or minus 4. But why aren't we putting minus 4, just plus? It's because we cannot have length being a negative. So the answer will be just 4. So let me position this correctly so that you can see my working. Let me run through again. What I did first was determine what type of triangle this is. The 90-degree helped me to know it's right angled. Then I knew then I have to apply the Pythagoras theorem. So I wrote it down. And I had to define what A is. A is the hypotenuse, so it's 5. B is 3, and C remains. Then I inserted the numbers into the theorem or equation. 5 squared is equals to 3 squared plus c squared. Then the 3 squared, or the positive 3 squared, had to go over the equal sign to become the negative 3 squared. So we are saying 5 squared minus 3 squared is equals to c squared. 25 minus 9 is equals to c squared. The 25 minus 9 is 16, so 16 is equals to c squared. We need to remove the to the 2 effect, the squaring effect. We introduce the square root. Square both sides to maintain the value, or to balance the equation, until we finally get c being equal to 4. I encourage you to pause at this time and draw this triangle on a separate piece of paper with 3, 5 and c, and try on your own to find c, comparing your solution with what we have here. And it's best if you try and not peep into the solution, because it is only through practice that we can be able to do mathematics more properly. So let us cross over to our example 2 of base application 1. Okay, so this is base application 1, example 2. We are given a right angled triangle because of this 90-degree angle, and we have A, B, C as points. AB is 20 centimeters, BC is also 21 centimeters. We are tasked to find AC, which also happens to be the hypotenuse. So now we have to put the Pythagoras theorem. So what will it be now? Since we are having AC, so we have this point. So this line will be called AC. So AC squared, the hypotenuse squared, is equal to, this line is BC. I encourage you to just respect the alphabetical order. So BC squared plus AB squared. Now, what is AC is what we are looking for. What is BC squared? So BC is 21, so we have 21 squared plus AB is 20, so we have 20 squared. So what is 21 squared? So you insert it in your calculator, you are sure to find 441. Plus, what is 20 squared? Set it again, you are also sure to find 400. And if we add these two, is 841. And here we can actually follow through with just writing AC squared, AC squared. What do we do if we want to remove the squaring effect? What we do is we introduce the square root. The square root. So the square root of AC squared is just AC. What is the square root of 841? So your calculator in this case should help you to find 29. If you are interested in how to calculate or find the square root without using the calculator, comment in the comment section, or actually write me on my email, and I will show you how it's done, or I will record a video showing how it's done. So our answer will be 29. So we have only done base application 1, examples 1 and 2. I know I've promised to give a take homework or just a question you can practice on your own. So I will write it down and we see where to go from there. So you can pause and appreciate the question. That's the take homework. So yeah, sometimes people confuse my A with 9. This is A, not 9. So that's the triangle, 8 centimeters, 15 centimeters, and A. Find the hypotenuse. So you know about the attention span. we all have different attention spans. It's more wiser not to make these videos unnecessarily long. So the second base application of the Pythagoras theorem, where we will be determining if a triangle is right angled or not, will be a subject of the next lesson. For now, it's goodbye. Thank you for supporting. Thank you.